Slope of a tangent line to a graph. In this lesson, our objective is to discuss the slope of a tangent line to a graph. Calculus can be used to solve certain fundamental questions in geometry, one of which is, given a function f and a point P on its graph, what is the slope of the line tangent to the graph of f at P? In other words, what is the slope of a function such as this blue function you're looking at in each of these pictures, y equals f of x? What is the slope of this function at that specific point P? Another way to ask that is, what is the instantaneous rate of change? The rate of change of a function at one point in time. That's a huge question, and that's a tough question. So let's start with something simpler, such as the slope of the secant line. In this first picture, we have the same tangent line, that's pink, and the secant line, that is green. If I asked for the slope of this secant line, because you see 2 points on the line, that's going to be easier to evaluate. The slope of any line is change in y, delta y, meaning change in y, over change in x. In Algebra 1, we've learned that that means, and I'm not going to use an equal sign, I'm going to use an arrow saying, following from that is the y values subtracting from each other, the difference in y is y2 minus y1 over x sub 2 minus x sub 1. Now, if I label in this graph that point P is at the x value C, usually we call C, the x value, the point of significance, the point that we're looking for, and then the other point on the green secant line as a different x value. Then we could further show the slope of the secant line as, in the denominator, the change between the second x value and the first x value, the difference in the x values, over the difference in the y values. And we get y values by plugging them into the function. So this x value goes with the corresponding y value, f of x, and the x value c goes with the corresponding y value, f of c. So we get the change in y, f of x minus f of c, over x minus c, and that would be our slope of the secant line, also known as the average rate of change. Now, if we want to use the slope of that secant line in order to find the slope of our tangent line, there are some ways that we could explore this. Notice that on the way from this graph to this graph, we're taking many steps in between, and notice what we're doing with the 2 points on that secant line. We're bringing them closer together. Here is C, here is X, and then even closer together until ultimately those 2 points are exactly the same point. Now, what is that called as we bring X closer to C? We're bringing this X value closer to that C value. Notice that change is getting shorter and shorter. That's called finding the limit. As X gets closer to C of that average rate of change, f of x minus f of c over x minus c. And this is called our instantaneous rate of change. And this would be the slope of our function at that point, the slope of the tangent line at point P. Since this and most of our calculus questions can be answered using limits, we need to know how to find a limit. Thanks for watching.